Excellent. Well, thanks again for the invite. My name is Alejandro Primera. I have been in the industry, in the oil and gas, for 17 years. And just very briefly, I've been working, or I initially started working as a reservoir engineer, especially working in reservoir simulation models. And I have seen a transition in my career for the past, I would say, 3 years. Actually, the kind of the peak of the transition to kind of a digital transition. But I would say that it's been happening already for 7 years. So 7 years ago, I started doing consultancy, and I for my founded my consultancy firm in the UK, and Primera Resources. And my experience started to migrate into programming, a lot of programming with R and C# at the time, where I was doing things like uncertainty analysis, proxy models for reservoir simulation models in R, reading and writing files with C#, and there was a lot of Visual Basic at the time. The past 3 years really is when I have migrated to Python, and coming from a background where I have seen a few different programming languages, I decided to stick to Python for the past few years. And I'm going to try to tell you why. Obviously, I'm not here to sell you Python, but I'm going to tell you why it's so important nowadays. And during these 4 days, coming 4 days, I'm going to show you some of the some tools, some examples that I have developed over the past few years. And we will start from very basic examples, and then we will build up to more complicated examples as we go forward. Just to set up the expectations, I'm going to start from the assumption that I'm not going to explain a lot of things from the point of view of programming. And I think there is a homework that you would have to do outside of these sessions. And you will have to figure out things like variables and statements, control flow statements, if-else statements, data structures, and so on. I'm going to give you some fundamentals libraries so you can tackle the hackathon, or very immediate challenges that you may have. But I guess if you really would like to progress within Python, you will, after these 4 sessions, you will need a more formal training on and deepening into Python. So let's see how much we can do. Going forward with the presentation. So why Python? Python has been growing quite rapidly the past 4 years. It's a really huge force in the open source and commercial domain. And when I mean open source, it's a lot of the good stuff happening open source that commercially or open source, a lot of companies are actually taking advantage of this ecosystem. So multiple libraries that are evolving and exploding around Python. A lot of companies are using those, and there is a lot of contributions towards those towards libraries in Python, and are becoming very stable solutions for companies. It's very easy to start with in terms of once you sit there and you start programming, there are things that you won't have to do, like declaring variables. It's something that you won't have to do. If you have been working with Visual Basic or C, C#, C++, you will know that you have to declare what is the type of variable that you have to use, and so on. Python works in a way as with this philosophy of a duck typing. Duck typing, meaning that if it moves like a duck, and if it looks like a duck, it's a duck. So we're talking about variables. If it looks like an integer, if it looks like a float, if it looks like a string, so be it. Um, the other really the power of Python is that these libraries that are evolving one on top of the others, other libraries, with a lot of strength in the communication of how they are building one on top of the other. So there are libraries that are becoming almost like ubiquitous across Python, um, the Python landscape, like NumPy and Pandas. And this is actually making more complicated and sophisticated codes to evolve on top of these libraries. So that is from the point of view almost of from the detail of let's say the granularity of Python now. So, but let's abstract from a second out of the granularity and why the Python has been a success from the point of view of programming, and let's talk about the application. And I have a few examples here where I have seen personally how Python is so strong. So database lifecycle. So from the point of view, and when I mean lifecycle is from the point of view of, or from the point that you are creating a database, let's say as SQL database, actually in SQL and most of the flavors of SQL like MSQL or PostgreSQL, you can create a database server, you can create the particular database, the particular tables, and you can have complete control of the entries that you have in the database, delete, add, or edit the rows and entries that you have in every one of the database, and also manage relationships. And in fact, there are libraries so advanced in Python that you can declare not in SQL language, but you can declare in Python language the whole database structure. So it's really powerful in terms of database management. Machine learning, and it's I guess that you have heard about libraries like scikit-learn. But what it really means that you have, what do we have within Python that is so powerful for machine learning? Well, a lot of the libraries are building on top of these foundational libraries like NumPy that I mentioned before, and hence they are becoming quite efficient. And we're talking about libraries like scikit-learn, where you can perform from a linear regression, logistic regression, that a lot of people won't call it machine learning. These have been techniques that have been around for ages. Well, most of these techniques, even neural networks. But if we put it there in the whole bag of machine learning techniques, you can start to work with decision trees. You can start to work with even random forest, which is a superset of decision trees, where you are pretty much building multiple decision trees in this machine learning technique. You can also go up to the point of building sophisticated classification algorithms. There is a whole process of evaluating the data, or the exploratory data analysis, feature extraction, feature analysis, that is all covered within the libraries in Python. And with libraries like TensorFlow and PyTorch that are being developed by Google and by Facebook, and are completely open source, you can even put together your machine learning models for using neural networks. Also, in unsupervised machine learning, you have also techniques like hierarchical clustering or k-means, where you can have a look at the data and start to classify, create clusters within that data without necessarily knowing any particular information about the data prior to evaluating it. So, and everything is within that ecosystem of Python. Web apps, I guess a lot of you have heard things like PHP or Node.js. So well, Python actually has a powerful web app or web server that can help you to build web apps. So you can build a website within Python. You can use frameworks like Django or Flask that can be as simple as creating a static website that is responsive with certain input from the user, up to creating a website that is more complex with a content management system where you have a database on the back end, and Python is actually managing the whole database from the web app in the web server. So really powerful. Things like sensitivity analysis and uncertainty propagation. Again, you can create sample cases using experimental design techniques in Python, or even do again sensitivity analysis with some of the regression techniques that I mentioned before in machine learning. And also you have multiple ways in which you can propagate uncertainty using Monte Carlo techniques, for instance. There are multiples optimizers in Python, multiples. There is a very strong library called SciPy where you have a large setup of optimizers, but there are many more that are available in many other libraries. Workflow automation and all the part of or ETL. So all the mundane daily activities of engineers that usually takes, in the past, it used to take 70–80% of the time that you could automate. Python, it's very useful for those tasks. So let's say you get a report every day, and from that report, you want to send just a few parameters to an email to your boss. You can automate, read that report, let's say it's in a PDF or in an Excel, in a CSV file, read it from your email, load it into Python, extract the words that you need, the fields that you need, put it in an email and send that email. So rather than the process of copying and pasting every morning that report, copy it, and that may take probably 10 minutes to half an hour of your time every day, you can automate this task. I'm not saying that, and this is the kind of things that restaurant engineers used to do, or production engineers or engineers in general used to do 5 years ago, and everyone is looking at ways to optimize from the little things up to more complicated things. A graphical user interfaces. This is an area where I don't think Python is extremely good. I think there are other tools that are better in Python. However, there are some libraries where you can build your own graphical user interfaces. I think there are programming languages that are, especially when I mean graphical user interfaces where you are pushing a button and then you're expecting a plot to behave in a particular area of your application. Talking about desktop applications, for instance, no website applications, but desktop applications that are fully loaded, that has entries, drop downs, and these kind of things. However, there are some interesting things on the area of dashboarding, and there are quite a few libraries that are very strong for dashboarding. And with some effort, you can reproduce something similar to what you have in Power BI, or something similar to what you have in tools like Tableau or Spotfire. Extract, transform, and load. It's this process again of continuously getting some data, extract some information, and transforming it into something that is useful. Let's say you have a production report or production information from the field every day, and you want it to fit it into your database. It's coming into a particular format, and you want to read that format, transform it somehow into an input that is suitable to your database, and then ultimately load it into your database. And as we move also into the data analytics, of course, everyone knows that Python, it's there for data analytics. And Python has been inheriting a lot from R over the years. One of those things is data frames. and that are foundational support to having a look at the data, explore, dissect data, filter, and so on. So exploratory data analysis in Python from the point of view of extracting data and visualizing data, it's very powerful. There are not only a couple, but there are quite few libraries for visualizations that are very strong in Python. And there are things that you won't realize that are happening on the application. There are things that are happening that are more or less in the background. There might be code that is in C, C++, even JavaScript, and you don't even realize that that is happening. It's Python really working as a high-level programming language that is hiding a lot of those details for and making the life easier for you. Integration with other platforms, I put those, I was going to put a lot of things here, but then I didn't want to mention a lot of, let's say, oil and gas related applications. But there are commercial applications like Power BI and Sportfire where you can actually integrate your Python code. Orange is a quite nice one, and I would recommend you to have a look at Orange. It's a more interactive tool. You can do a lot of nice stuff that you would do in Python through coding, but Orange also have an access, a direct link to Python where you can embed your codes there. Another thing that I use sometimes is QGIS for mapping and geospatial data. And there are commercial tools within the industry that are moving towards a Python integration. So some applications, and I put here my experience because I like to mention that these are things that I have done. It's not something that I have read in a book that I think that can be done in Python. These are things that I've tried myself, and they are actually working. And I think that you could do it yourself as well. So things like taking some deviation surveys from multiple type of input reports or input type of data into the Python world and visualizing it in 2D or 3D. That's something that it's quite feasible in Python. Let me see, this is another one where there are libraries already available where you can read your last files and the deviation files as well. You can read the last files with the petrophysical information. Prior to interpretation, you can do some interpretation in Python, and then you can generate also your logs and your interpretation. I have combined pressure data from MDT, PLT data from production logging tools where I have oil, water flow rate on a well, and with the log interpretation, I put together a whole canvas. Don't know why this is a bit cut, but you see here at the bottom the more or less the idea of a plot. There are other things that are more advanced, like working with reservoir simulation models. And I have been working with open source libraries where we can manipulate the reservoir simulation models, launch simulation cases from Python, and also extract some of the simulation results from the 3D or from the plots. And with that, I have done also things like getting the simulation results and producing dashboards directly into Python with libraries like Dashplot. So these are all things that bunch of things you could do with Python. Also, other things like reading a lot of simulation files, reading the simulation results, producing multiple simulation scenarios, and then ultimately evaluating economic models that we have built in Python. And this is an example of how Orange looks like. And this is an example where I have built a few steps within it, where I have Python integrated to read some of the data, to clean some of the data, and to perform some machine learning with the data. So it's a combination of Orange and Python. I would really recommend you to have a look at Orange. So before I move forward, I also wanted to mention, I think this is oh yes, this is a more kind of a complicated or more complete approach or example. And in this case, I have, just a second. Yes, in this case, I have a few simulation results from a simulation model. The simulation results are read by Python and stored in a web server. The web server is built completely in Python, and we can generate APIs that are almost like connectors that allow us to serve the data from the Python web server remotely to anywhere we want. We can also feed the data to the web server from Excel or from external databases to other APIs. And also, in this case, I have my local PC where I'm reading cost information from the web server. I'm reading the production data that I have extracted from the simulation results. And I have an economic model that is in Python, and I have KPIs to visualize the simulation results directly into Python. So, and this is to give you an idea of how powerful could be the ecosystem of something that you could put together in Python. It could be as simple as reading a file and extracting some information from that file, up to something more sophisticated like this, where you have a web server, you have APIs in Python, you are reading binary files from the simulation results, and you're ultimately also have an economic model in Python and dashboarding in Python. So before I move into how to start in Python, I would like to mention some of the resources that we have available. And just give me a second, because I forgot to put that slide in the deck. Let's see if you can see that. Yeah. So I founded a Slack community where we have petroleum engineers and geoscientists interested to learn about Python. We have more than 800 members already. So if you are interested to join, I can send you the details in Slack and send you an invite. And I hope that this year we could push for more members and more activity within the Slack community. We also have a GitHub repository where we are slowly building a series of Python, let's say, not only tutorials, but also libraries. And the idea is that as we progress, we have more libraries that we can share. At the moment, we have some libraries for material balance. We have one for production system analysis, and we are building one for decline curve analysis. But the idea is not that I am I'm the only one contributing to this library, but the idea is to create a community that builds around those libraries. And finally, we have a YouTube channel. If you have time, have a look at the YouTube channel, because there are quite a few videos where we do live sessions on every now and then on Python. This is very far from philosophical discussions about what you can do and so on. It's actually hands-on examples of that we take from our daily work, and we try to show people how to do things. So if you have a time, please try to go to those resources. I will send you in a bit the Slack community link, because at the moment it's working by a direct invitation. So to move forward and to start to do some hands-on things, there are multiple ways to start with Python. And I think, I don't know if you can mention in the chat, some of you, if you have a struggle to start with Python, or more or less, just write in the chat, how do you feel about Python at the moment? You can say simply, I don't know anything. I don't know anything about programming. I don't know anything about Python, or my experience is more with these other languages, or I'm a super expert in Python. I don't know what I'm doing here. So everything is valid. I just would like to understand more or less in the chat before we move forward. How do you feel at the moment about Python? And if you have a struggle to start with it, please, if you can put your comments in the chat. Well, C, C++ is quite something. Very comfortable with R and SQL. You're going to feel like very comfortable with Python as well. Java and VBA, that's very good. Good. Okay, PostgreSQL. Okay, Stack Overflow questions. Modern knowledge of Python, brand new in Python. Good, took a lot. Okay, whole course, excellent. Fernando. Lorraine says that C and C++. Okay, you will find Python very easy in Python, good with SQL and VBA. Have you tried to get into Python, and do you find it like there are many ways to start and it's a bit confusing? No? Yes? Easy to start with Python when you started? Very simple for a new user. Yes, easy to start. I think great. Yes, exactly. Yes. So my experience as well has been exactly that. Once you start to sit and work with some Python lines, it's very easy to start. But the problem is all this ecosystem of IDEs that are around Python. And I guess, I don't know if you have suffered this, but when you start to work with Python, you have a lot of examples that are some tools like PyCharm, or you have code, and you have also Jupyter Lab, Jupyter Notebooks. You have Google Collab. You can start to work on your directly on your console as well, and start to build codes directly in the console. So there are a myriad of IDEs, integrated development environments, or Spider as well, from Anaconda, where you can start with Python. And if for some of you that are just starting with Python, I'm going to jump ahead, and I'm not going to worry about things like environments, installing Python in your machine, and working with environments. That is something key that at some point you have to learn. But to start with, all this, we're going to go and we're going to use a Google Colab. So what I think it's good about Google Colab, it's not my tool of choice to program, but let me start from the beginning, from scratch, and I want everyone to do something today in Python. So I'm going to start with my Google from scratch, and so if I go to Google Colab, I already have an account, and the first thing that I'm going to do is I'm just going to write here a new notebook. And for those that haven't used any integrated development environment in Python, or that haven't even used Jupyter Lab, usually what I do is I use a mix of Jupyter Lab and PyCharm, a bit of VS Code, but Jupyter Lab and PyCharm are the kind of tools that I use. Google Colab, it's very similar to Jupyter Lab, and I'm going to show you my Jupyter Lab, which is actually running on my computer, and it's one of the. So this is Jupyter Lab. As you can see, you have some cells here where you can run your code, and you can put also cells where you can have some information. So I'm going to try to build that exercise as a first exercise in here. And as I go and start build the exercise, I will also explain some of the stuff that we have in Google Colab. So one of the things that you can see here is that within this cell, I can do things like setting variables where I'm going to do A is equal to 1, B is equal to 2, 3, and I can do things like A plus B. And that is actually connecting to a machine served by Google, thanks Google. And I have some allocation of memory and RAM. And there we go, we have our answer back, okay? That's fine, that's great. One thing that you can see, it was super easy to start. For those of you that have worked with C and C#, you know that you have to declare all those variables, and you know that you have to especially report this return to a console or something. No, here it was very easy to start with. Just let me close. Sorry, let me close this. Now let's do something a bit more interesting. Let's say I want to use. I want to do. I think I want to do a logarithm of a value. So I want to do access a math. There are some. I want to do something like this. I want to do math log of A. And let's see what's happening here. So I have a library called math that I need to access and in order to execute this bit of code. So if I want to run that, I'm going to add a code here. And you can see that I can move this code around by moving it up or down. Yes. So I'm going to move it at the beginning, and I'm going to start setting up a few things that I want to import. So I want to import that library called math. And now that the library is import, you probably haven't seen, but I just hit Shift Enter to run that line. So I can click here, run the line as well. And if I click here, hopefully I should have the logarithm of A. Okay. So it's a mix of a couple of things. This is importing libraries. There are other important libraries that you will learn are super important, like NumPy. And you can actually publish, if you ever write a library, you can publish your library, and your library will be available here to be imported. So usually the libraries, if you want to see so what's happening on the background, there is a place called PyPy or PyPy. PyPy, I'm not quite sure, where you see a lot of all these projects that are published. So if I go to one of the most relevant ones, so you have NumPy, and you have, this is a NumPy library. So when I do import here, what I'm really doing is pretty much downloading the package from or not downloading, or using the package that is installing the machine. Or at some point, if I want to use a library that is not available, and I need to download from PyPy or PyPy, you should actually install the library. And I'll go to there in a second. So as you can see, I can add quite a few lines here, and as I progress in the code, I can set up all my variables. Let's say I want to set variables like porosity equals to a value, permeability equals to another value, and so on. Okay? So I can set up all my variables in this box. The other thing that I can do is add some text here and put certain ordering in the way I'm declaring my variables, in the way I'm importing my libraries. So let's say I'm going to set initial variables. So that's what I'm going to do here. And of course, we can change the size of the font and so on. And I think there is a bit of rules here. You can add some markdown here. So if I put hash or 2 hashes, so that's the size of this text will change. And this is basically indicating that this is a title or subtitle and so on. So you see, I'm going to set my variables, and in fact, I'm going to reduce the size of this. I'm going to put 3 hashes, 3 hashtags here, 3 numerals there. And I'm going to add another one at the top. And I'm going to add a name to this book, and it's going to call inflow, and let me put a hashtag inflow performance calculation. And this is what we're going to try to do. So an inflow performance calculation, I'm going to set my variables here. And I'm going to, first of all, import libraries here. Okay. So I'm setting up my libraries here because this is setting up some variables. I'm going to move it here. And I'm going to do some, let's say, again, I need to set this up as a text, and then we're going to execute code somewhere here. So this is where I'm going to do my calculations. So far, you could see how nicely and tidy up this could be. In fact, you can import also images to this notebook and some things that you could do as well. Let me do something like save a copy. Let me save and show you the different formats that we have here. You can download the .py. .py is pretty much giving you only the code, but you can also download this is the notebook itself. And once you download the notebook, you can also open it directly into your local Jupyter Lab or Jupyter Notebook environment. So that's something interesting to do. And I don't know if I have, but the option to export it to HTML, but that is also quite useful to share the code in a way that you can display it on a website if you need to do so. And okay, so far I'm going to pause for a second, and I'm going to ask you to make sure that every one of you have access to Google Colab and start to do a couple of operations there. And let me know in the chat if you have executed those operations, please. So I want everyone to make sure that you have access to Google Colab and do a couple of operations and add at least one line with some text and one line with a couple of code, and try to do that example of executing the math.log. Sengun, Kelsey, Joseph, are you giving it a try? Excellent. Just give it another couple of minutes. Excellent. Was? Xiang? Okay. You good, or you already managed to open Google Colab? Just wanted to make sure that you can open and do some stuff there. Okay. Awesome. Awesome. Right. So we have 15 more minutes, and the next thing that I'm going to do is execute as a very simple problem from a book of the book of petroleum production engineering, computer assisted approach. Let me see if I can copy the image from. Okay, let me do a snapshot and see if I can. I haven't tried this in Google Colab. I know that I could do this in. So I'm going to try to paste here some image. Oops. Let's see what happened when I do enter. There we go. Okay, so I copy an image, and there we go. We have the image there. So what I want you to do is that we have this problem. Just to give you a reference of where I'm getting that problem from, I'm going to move this 1, 2 down. I'm going to remove this. Actually, I can remove this cell by delete cell, and I'm going to add another line here of text. And this is a problem statement. It's very simple. And what we want is to run okay. So given this information, we want to calculate the transient flow at 1 month, at 1 month, steady state flow, and pseudo steady state flow. Okay. So before I set up the variables, let's put where we want to execute the code. I want here to produce transient flow at 1 month. Okay. So you see that this is not showing at the moment. You have to be careful because you have to make sure that I don't know how to convert it actually, but this should be a it should be a cell. Open it settings. This should be a text. Let me put a text here. Oh, what's happening? Okay, there we go. So I'm going to do something. I think it should work here. I know that it works quite nicely in Jupyter Lab, and I'm going to try to write a LaTeX equation here. So let's say I want to write a simple equation, which is J equals Q over dp. Okay. Oh, okay. And I have to close it. Let me check that it works. Okay, there we go. So yeah, this is very nice because you can write also your equation. So as you start documenting your problem, you can also write the equations directly into your notebook. So I'm going to write the equation for the transient flow at the first month. I'll try to figure out the code. It's a bit late for me, but this is the code. There you go. And what I'm doing here, it's as you can see, I'm doing a fraction kh over the rest of the kh is the numerator, and in the denominator I'm setting up the rest of the equation, which in fact is up to this point. So I can use this fraction in different places of the equation. So as you can see, I have a fraction here for this term within the log, and I can use also Greek letters like theta. So very interesting way to document your notebooks. So I'm going to write a couple of questions here. Probably I'm going to leave those to you to figure out how to do it. So first one is transient flow. The second one it's going to be steady state flow. And the third one is going to be zero steady state flow. Right? And I'm going to put the equations there. There we go. So what we want is as we have this line, we want to add a line here to execute that piece of code. Okay. And very simple. I could use the math library that I imported at the beginning, and I can do the operation and return the equation. So if I set up all my variables, porosity, permeability, and so on, I can execute this code. So I'm going to send you this exercise for you to finish it. And please, for the next session, if you can just give me these three values and execute the notebook. So set up your variables. I'm going to remove this line here. Set up your variables and execute these lines. It shouldn't take you long to figure things out. And play a bit with the notebook and see what you could do. So that's the first one. And for the next one, I'm going to give you a heads up and tell you more or less what we're going to do. So for the next one, we're going to work with a more advanced library. We will be using NumPy, and we will have a decline curve analysis example. And in this case, we are going to just give you a few, one well with production data. And in fact, let me save this notebook as exercise 1. And I'm going to save this. And let me download it, and I'm going to put it in the chat, so for everyone to have a look. And for the next exercise, let me open a new notebook. And So this is an example. Right, this is a statement. So we have some monthly average oil production rate from this well. This is public data, and that well it belongs to Vaca Muerta, Loma Campana concession in Vaca Muerta in Argentina. And the idea is to try to use one of the decline curve analysis equations and see how it could fit initially manually into this data. But I guess as we progress, we can try to see, and you can do it yourself and see if you can use some of the Python libraries to um, to to make a fit on the equation. Can you share the doc where you copy the equation from, please? Don't worry, because I'm going to share that notebook, and you will see the equation, and you will see also the format that I used to build that equation. So you will have that as well. So this is a problem, in fact, where I'm not going to introduce a NumPy yet for this problem. We're going to use a time map, and I'm going to give you some of this data. We have a date, and if you see this information here, you can see, can you tell me what type of data what type of variable is this one in here? Yes, yes, Fernando, it is a string. And if I run, so if I run here type and the name of that variable day, actually I shouldn't be using that, but that's fine. Let's use 8. You can see that this is a string. So this is a type of things that Python will do. You set up a string, and actually I'm pretty much stating that it's a string by enclosing this the date and time in quotes. So somehow we have to do some operations with that date and time that is within quotes. But what I'm going to do there for the next session is work out for this well and this information. We're going to work out what is the best fit for a decline curve analysis using a Dwan equation, which is one that is used that we could use in unconventional. And just to give you an idea of what is the Dwan equation, let me use one of the suggestions from Fernando. Fernando says that if I do Control MM, so if I put this as a text here, and I do Control MM, yes, I can convert this to a text. Thank you, Fernando. I guess I will work as well in Jupyter Lab. Okay, let me see. Control M. Oh, I see. Control MM and Control MY. Thank you, Yasser. So there you go. So we have the Dwan equation, and this is a bit more complicated than the previous example because we're talking about time series. There are quite a few numbers, and there are different ways in which we can do this. So I'm going to do for the next session, I'm going to do a couple of approaches where I will show you what is the way to do it with an array. And then we will introduce NumPy and do something more, and probably introduce some visualization with Matplotlib as well. Okay. Do you have any questions or comments before we close out? No? So for those that is the first time having a look at some of these, please let me know. I probably can stay probably another 2 or 3 minutes, and if you have any doubt, doesn't matter if it's very basic, or if you have doubts or something more complicated that you want to discuss, please let me know. I can be connected here for another couple of minutes. Let me send you these couple of exercises. Perhaps you can start working with this data by yourself. Exercise 2.